So today we're building a hash map. So what is a hash map? A hash map is like a smarter way to organize a massive collection of items, like a library or a warehouse, for example. So first look at this green column here, numbered 0 through 7. These are called buckets. Instead of searching through one giant pile of data, like for example um, an array or a list, we actually split the data into 8 different buckets. So let's say we want to store something like a key. Let's say a key like a username. The computer uses a formula called hash function, which actually tells us which bucket number the data belongs in. So it's like if you want to understand more, it's like a GPS. It's like having a GPS for your data, so you don't have to guess what it is, right? So now look at the blue buckets or the blue boxes here, the blue boxes. Sometimes the formula actually gives us the same result, which can lead to collision, right? So instead of crashing, the hash map just starts a chain or a linked list, as you can see in the bucket 0, 3, and 7. The items just line up behind each other, like this. So I think now you have the basic understanding of hash maps, and we can actually start to code. So I actually have already set up the hashmap.c and hashmap.h here. So I'm gonna just add a main.c. gdiu.h, the basic stuff. So let's now create the structure of the hash map. So structs. So first of all, let's say if and def, if not defined, hash map h, then define it like this. Cool. So now let's start. Let's say struct hash map. And in a hash map, we are going to have, as you can see here, a list of entries and also the size of the hash map, right? So why a list of entries here? Because it's a linked list. So each element actually chains up to the others. So first of all, we're going to have an entry. So struct entry, which is gonna have entry next, a key and a value, which is gonna be car key, car value. You know, everything to car, just to keep things simple. So now the struct hash map is gonna have buckets, which is simply let me just add type def here. Type def struct, yeah. I'm gonna have here entries. Let's call it buckets, as we said. And we're gonna have a size, which is integer. Yeah, like this. So I think now we're good for the basic structure of the hash map. So let's now add the methods we want to implement. So we can first start with implementing how to create the hash map. So creation of the hash map. What else? We can actually add elements to the hash map, and before that we're gonna have a hash function to hash our keys. And let's say also we're gonna have get elements by keys, and yeah. So let's start here. So let's start by including our hashmap.h, and let's start also by defining our function. So the create hash map is gonna be of type hash map, pointer of hash map, which is, how do we name it? Create hash map, which is gonna take, do we specify the size or do we put a default size? I don't know. Let's say we specify the size, right? There's no implementation in the .h. The implementation is gonna be only in the hashmap.c here. So let's do that. So hash map, if I can type hash map in size, and we're going to allocate memory to let's say map, which is going to be a pointer, of course, malloc size of hash map. We also need to allocate memory for the element that's inside. So in this case, the buckets. So map.size, let's also specify the size here, which is going to be size. Oh yeah, I forgot to specify struct here, and struct, hope it's correct. Yep. And also map buckets also is gonna be equal to malloc. Actually, just use calloc because we need to initialize the values that are inside of the hash map. So it actually contains 0 as, I mean, an initializer. So calloc, we take some parameter, the size t and memory here, allocates n elements. So the number of elements we have in the list, so map.size, and the size of on a pointer of entry. So it's like this. Yeah. And then what else do we need? I think we got it. Now we just return the map. Where's the error here? Must use struct tag to refer to entry. Just didn't save. Now let's try to add this to main.c to test if it compiles or if we have any errors. So we're also including hashmap.h and also map is equal to create hashmap. Let's specify 8 elements by default in the map. and of course it's a pointer. And let's try to compile this. gcc main.c and also hashmap.c. Create hashmap. What is it saying? Create hashmap. Invalid initializer. Invalid initializer. What does that mean? Invalid initializer. Did we do something wrong? Hashmap.c. Okay, I think we can also create a Makefile to make things simpler for compiling. So let's just create a simple Makefile here. Makefile, let's say results. And result, we're gonna need hashmap.c, main.o, and main.o. You can specify the CC as GCC, also the C flags as G for debugging, and also well for all the warnings. So it's gonna be CC and then C flags, then dash O, hashmap.o, and main.o. And for hashmap.o, we're gonna need hashmap.c and hashmap.h. And we can do this also, dash C, and just specify the first element. So this means the first element in the list of the files here. So we are only compiling C files, not H files. H files are not compilable. And now we can do this also for the main. So the main also needs the hashmap.c, like this, main.o. And we are also gonna need a go. If we create a go here, we can say it's just gonna execute the results we are compiling. So let's test this. Make yeah, exactly. So unused variable, that works perfectly, I think. LD, there's an error here. Undefined reference to create hashmap. Makefile. Main.o. Did we miss something here? For the result, we need hashmap.o, map main.o. Hashmap.o is here. And what was this character? Okay. So let's make sure it's compiling without. I think, do we specify the C here or main.c? Oh, I don't think we're specifying anything here apart from the main.c. The hashmap.c is also compiled in its own let's say environment or something like that. So where's the error coming from? Is it line 5? Oh yeah, sure. Results. Make, yeah, exactly. now make go. Okay, the code is working, and we can also add round.sh just to do the make and make. So actually it's shebang user bin sh make and make go like this, and chmod plus x, what's the name of the file, run sh, and actually we can run the sh like this. Cool. So now let's get back to our code. I mean, let's see, it's working here. The code is working. It is actually creating the hash map. So that's now. Let's create now the hash function to hash the elements before inserting the keys in the hash map, the keys and the values. So let's add the hash function. The hash function is simply gonna be unsigned long hash, because we only need positive values, and the long because the elements in the hash map can be of various length. For example, 1 million, for example. So actually it's a known algorithm called the, if I remember, DJB2, I think. So we're passing the const car key. If I can type const car, the key, the value, like this. Sure. So now the algorithm is going from unsigned long h. So it's going from a starting point, which I remember being 753A1, I think. I mean, we can look in DJB2 algorithm hash, which, yeah, 5381, like this, and then while for each character in the key, we're actually using this to change the hash function. So h equal to hash plus h, and then plus c, and then we're returning the hash modulus the size of the map. So I think we should also specify the size here. So size modulus size, so to actually stay and not get out of bounds. So we can also test this in the main. Let's see. So let's say assigned long hashed, it's going to be equal to hash here. The key, let's say it's hello, and here it's world. What is going on? I think we also need the size here. Call to function hash. I don't think it's calling the correct hash function. Call to, I think there is a hash function which is in the built-in library. I don't know. Call to undeclared function hash. ISO C99 and later do not support explicit declaration. Okay. What does that mean? Let's do something like to see if say hashmap h. Okay. Oh yeah, I didn't specify the size here. World, now incompatible, pointer to integer. Yeah, sure. I should specify also it to be a pointer, and we should be able to also print the hashed, so unsigned long, percent unsigned long, or lu hashed. And I think conflicting types, unsigned long hash, previous declaration of hash with type long unsigned. What did I do here? Unsigned long, right? Hashmap. See here, unsigned long hash. What is this telling me? Conflicting type of for hash. Conflicting type for. Actually, let's rename it to hashfn. Hashfn, and then go to hashc. Okay, it is renamed to hashfn. Maybe it's the name, I don't know. We still have the same undeclared function hashfn. So we have it, right? This is the hash function in the hashmap.c. Oh yeah, of course, const_value like this. Hashmap h const_value. We got it. Yeah. Const_key, const_value, and in size. Yeah. Const_key, const_value, in size. Yeah. So what's the error now? Okay, let's try to in C. Oh yeah, sure. I did something bad here. In C, while C is equal to this. Why am I doing this every time? Okay. So now we have implicit declaration of function hashfn. Did you mean hash? Did you mean hash? Okay. Okay. It is good now, I think. Yeah. Sure. So now we can come back to the main C. See the hashed here. You can add a \n here, and also hey, and you can see that. Yeah. So as you can see, for each key we pass in the function, we're getting the hashed value, and the hash value modulus 20 to actually stay in the scope of 0 to 20. Yeah, 0, 20, or 19. Yeah. So the hash function is working now. So now we're going to use the hash function now to actually insert the elements in the hash map. So it's gonna be a void insert. We're gonna have a map, hash map, and const car key and the value. And be careful this time, const start key, const start value. Like this. Okay, so let's now insert elements in the map. So how is this gonna work? So we have buckets and we want to insert elements. So actually we can rename this to be insert or update, like the basic behavior of hash maps in high programming languages like Python, Java, or else. So we're given a key. So with this key, if we find an element that corresponds to the same value, we're actually going to update with the new value. I mean, if it has the same key, we're going to update with the new value. But if there's not the same key in the hash map, we're going to insert a new element, which is gonna be a new head of the linked list. And the linked list of the hash map, the first element is the head. The first element of the bucket is the head of the linked list of each bucket. So how do we do this? Let's first check if the map is not empty. What does that mean if the map is not empty? So if map the size, not size. Let's say if map, if the map is null, it is empty. Is that correct? I don't think so. Okay, how do we do this? Let's say if map actually let's just do this like this, and then we're gonna come back later to see how we can make this better. So printf empty. So now we're going to need the hash. So hash the unsigned long, which is the let's call it index. It's gonna be equal to hash. So we're gonna find the buckets where the key is. Hash fn actually. Hash fn of the key. The hash, I think, yeah, the hash doesn't need a value here. Just the key and the size. Yeah. It doesn't need a value. You're not even using it. Sure. So it's gonna need the key and the size, which is the map size. Right. So now that we have the index, we can now know in which bucket is the current key, or if I can say that, the current key, yeah. So it's gonna be an entry, which is the current entry. So as you can see here, so by doing this, we're finding the index now, the index of the buckets, and now we do map buckets. So the buckets here are the index we found. So in this example, in this case, the index is index. Okay, so we now have the head of the bucket, which is the first element. So insert or update. So let's first cycle through the linked list to check if here let's cycle through the linked list here to find if there is an element that has the same key, and if it has the same key, we update the value, or we just add the element to the beginning of the list to make the finding to make the process of finding the element faster. So O of 1. Okay, so while current different from null, we're going to say what can we say here? We're going to say if strcmp, so comparing the strings, so if strcmp of the key and current the key, so equals to 0. 0 means true if it's the same. If it is the same, then we just need to update the current. So current, that value is going to be equals str dup to copy the string and with the new value, and then we return. I think that's good for now. Yeah, that's good for the first part. Now, if we get out of the loop, it means that the element is not found. So we need to add it to the beginning of the linked list. So it has to become the head now. Now, how do we do that? How do we do this? Map. If you went through all of this, then we now need to set. Okay, let's say entry. New entry is malloc size of entry. New entry that value is equal to value. Now we need to add this to the beginning. So new entry that's next is gonna be equal to map map buckets index, so the head of the list. And now the map that buckets, I think, do we need to do something else? Now the map buckets index now becomes the new entry, so now it becomes the head. Is that correct? Is that correct? Looks like yes. Correct. Looks like it's correct. Okay. Let's try to insert an element. So can comment this too. You can say insert or update, map, key, say hello, and world, like we did. That's one shot. So let's now say something like this. Still works. Okay, we're actually going to figure out if it's really working with the get method I'm going to do. So let's go back to our hashmap.h and add the get function, get hashmap map const char key const char value. Okay, so now if map the map is empty and return stdio, yeah, we got it. Oh yeah, I misspelled it. Now assigned long index, so basically this, so let's copy this current and then while current. Actually, yes, I forgot to specify current dot next here, or that will be on infinite loop. Yeah, so just remembered. So current dot next, and if we find if a strcmp of key with the current dot key, then we're just going to say return. It's not a void. It's gonna how do we do this? Is it car? It's gonna return a car. So do we exit or something? We need something to stop the code here. Just return, or maybe let's exit. Let's exit, or something like the map is empty, and then we just okay. Let's come back to that later. So to do come back later, and here if we find something that has the same key, then we return if, then return current the value. That's correct. Right. So now if we didn't find something, we need to return something. We need to tell the user that we didn't find it. So print, let's say return not found. This is not really good, but let's keep it like this for now. Say get map hello, And also here we don't need the value because that's what we need. Hashmap page. Don't need the value here. I don't know why I'm always specifying the value. Correct. So now let's const_char value, printf %s value. So now we should get something else normally. Yeah, we one-shot it down. One shot. That's crazy. One shot is crazy. So we can actually do this and update the value, and that would work. Run. Wow, that's cool. You can actually add something else like trends time, and we can also do this second value. The second value is not used. Okay, that's interesting. It says not found. It says not found. So I think there is a problem here. Let's do this to see if not found. Not found. So the current is get map at current. Pretty sure I wrote this correctly, right? Which is not correct. I think we're doing something that's not correct in the insert or updates, or maybe the get. No, the get is not found. Okay, is it this part or this part? I think we can use GDB to debug this, but okay, let's just do it manually like that to find if it's okay. So we actually know that it's not this part that's causing this. It is actually this part. So the current, okay. Unsigned index. So I think the video is getting long now. If you have the solution, and you can tell me in the comments, and if you have some suggestion for the next videos, also tell me. So thank you for watching, and see you next time. Peace out.